to our channel and click the bell icon for the latest update. Today we're gonna start with your physics, that is of part 1 for class 11, and that is your class 11 here. And we had done your class 9 for class part 1 for class 11th here, and that we had started, and which has been the important one as well. In the same way we talk about it, so we had last discussed about least count error. If you had not visited that, you can go ahead, you will find out each and every video there. Today we continue with absolute error, relative error and percentage error. So before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. Let's start it. Absolute error, relative error, and percentage error. Absolute error, relative error and percentage error, these all are important, so we have to discuss here in the detail. In terms of absolute error, we talk about here, that is your the absolute error that is, suppose that the values that are obtained in several measurements that are a1, a2, a3 till an. The arithmetic mean of these values taken as best possible value of the quantity under the given condition, that is of measured of, which is been as follows. A mean equals to a1 plus a2 plus a3 plus an n, or a mean equals to sum of n I equals to 1 ai by n. So this is because, as I explained earlier, it is reasonable to suppose that individual measurement that is likely to overestimate as to underestimate, and that the true value of the quantity, where the magnitude of the difference between the individual measurement and the true value of the quantity is called an absolute error of the measurement here. That has been denoted by the absolute where that has been denoted here is by a, and in absence of any of the method of knowing true values, we are considering the arithmetic mean as a true value, then the error in the individual measurement values from the true values that are being representing here. a1 minus a mean a2 minus a mean an equals an minus a mean. This delta a that has been representing here in calculated above be positive and have a certain cases and negative in some other cases, but absolute error that will always be positive. The next we talk about for the arithmetic mean of all absolute error that has been taken to the final mean absolute errors of the value of the physical quantity, which is being a, and that has been represented here. So we go for that. Main equals to delta a1 b A2 delta A3 AN by N I equals to 1 to A1 by upon N. If we do a single measurement, then the value will get may be in the range of A mean plus minus A delta A mean, and for that it will be plus minus A mean minus delta A mean is less than equals to A less than equals to A mean plus delta A mean. This implies that in measurement of the physical quantity A is likely to lie between A mean plus delta A mean and A mean minus delta A mean. Now we talk for the next is which is the C part that will discuss about your relative. So instead of the absolute error, we often choose the relative error and the percentage error. So that the relative error is the ratio of the mean absolute error, which is of delta A mean, to the mean, the value of A mean of the quantity measured, and the relative error will be representing here equals to delta A mean by A mean. When the relative error is expressed in percent, it is called a percentage error, where the percentage error is represented by delta A mean into 100%. And let us now consider an example that we'll discuss here, which has been the another question. So here we go for it. The question is, two circles are being tested against in a standard clock located in a national laboratory at 12 noon by the standard clock, and the reading of the two clocks are, so there have been two clocks that has been tested against the standard clock located. So we're on Monday, Tuesday, Wednesday, Thursday, Friday and Saturday with clock 1 and with clock 2. So for that we have to deal here. So let's go for it, as we have to solve it out, and that has been the important one. So we go for it. I will just tell you for Monday, and for Tuesday, for Wednesday, for Thursday, for Friday, for Saturday. If you are doing an experiment that requires a precision time interval and the measurement, which of the two clocks will you prefer, that is being asked, that among these two clocks, which clock you will be preferring. Okay, so that's what we have to talk about it, and then we'll do this next question as well. So I will do first this one so that you are be able to. Okay, so the question we have, this is the question 6 of this unit. Two clocks are being tested. We had done 5 questions in the last classes. Two clocks are being tested against the standard clock located in the national laboratory located in a national laboratory. At 12 noon by the standard clock. The reading of the two clocks are so we talk for clock 1 and clock 2. Okay, so first we talk here about the days that we have, and then we'll talk about for the clock 1, and this is for clock 2. Okay, now we go for it. This is for Monday. Then we have for Tuesday, Wednesday, Thursday, Friday, and Saturday. Then again we have your Sunday. Okay, so for clock 1 and clock 2 you have to measure it out. They had done an experiment, so we deal with this. For Monday it will be, for clock 1 is your 12 hours 0 minutes 5 seconds. 12 hours 0 minutes 5 seconds. For clock 2 on Monday, 10 hours 15 minutes 6 seconds. Now we talk for the Tuesday here, which is being here that we have to talk here for clock 1 and for clock 2. 12 hours 1 minute 15 seconds. For clock 2 it is 10 hours 14 minutes 59 seconds. Now for Wednesday we talk here, that is 11 hours 59 minutes 8 seconds. For clock 2 it will be 10 hours 15 minutes 18 seconds. On Thursday it will be 12 hours 1 minute 50 seconds. For the clock 2 it is 10 hours 15 minutes 7 seconds. For Friday it is 11 hours 59 minutes 15 seconds. Ten hours 14 minutes 53 seconds. This is 12 hours 1 minute 30 seconds and 10 hours 15 minutes 24 seconds. For Sunday it will be 12 hours 1 minute 19 seconds, and this is 10 hours 15 minutes 11 seconds that we have for Sunday. Now what you have to do in this particular question, if you are doing an experiment that requires precision time interval measurement, which of the two clocks will you be preferring? Okay, that you have to talk about it. So according to me, The range of the variations over the 7 days of the observation is 162 seconds for clock 1 and 31 seconds for clock 2. So the average reading of the clock 1 is much closer to the standard time than the average reading in the clock 2. So the important point is that the clock's zeros errors is not as significant for the precision work as it varies. So because the zero error that can also be easily corrected, so hence clock 2 is to be preferred to clock 1. Clock 2 is preferred to clock 1. Okay, that's what we have to answer it out. Now we deal with another question. This has been another important one. The question has been asked, we measure the period of the oscillations of simple pendulum in a successive measurements. The readings turned out to be 2.63 seconds, 2.56 seconds, 2.42 seconds, 71 seconds and 2.80 seconds. You have to calculate the absolute error, relative error or percentage error. So that is of course being important one, and that what we'll have to discuss here. So we go for it. So we go for it. That is your question number 7 of the session. We measure the period of oscillation of a simple pendulum in successive measurements. The reading turned out to be 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds and 2.80 seconds. Calculate the absolute errors. Relative error and percentage error. So we find it out and we'll have to answer it out here as well. The mean period of oscillation of pendulum. So the mean period of oscillation of the pendulum that is we have equals to 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80 seconds upon the number of counting we have 1 2 3 4 5 that has been divided by 5. It will be 13.12 on 5 seconds, and let me further cancel. We'll get 2.624 seconds. It will be equals to 2.62 seconds. Okay, now further we go ahead, and that we talk about here is being for this particular, we have to find out the percentage error, relative error, and the absolute error. So as the periods are measured in the resolutions of 0.01 second, all the times that are being fixed for the second decimal, and that is the proper to put this mean period also in the second decimal. So the error in the measurements are, what the error will be having, the error in the measurements are 2.63 seconds minus. So on the same way we talk about here, that is being another one, we'll find out the value seconds, will give you 0.01 seconds. The another we have 2.56 seconds minus 2.62 seconds, that will give you minus 0.06 seconds. Another is 2.42 seconds minus 2.62 seconds, will give you minus 0.20 seconds. Then another we have 2.71 seconds minus 2.62 seconds equals to 0.09 seconds. 2.80 seconds minus 2.62 seconds equals to 0.18 seconds we have. So here for this, that is, you have to note that the errors that have same units as the quantity that to be measured, where the arithmetic mean of all the absolute errors, for the arithmetic mean we take only the magnitude is, which is being as the mean, equals to 0.01 plus 0.06 plus 0.20 plus 0.09 plus 0.18 seconds by 5, which is equals to 0.54 seconds by 5, will give you the value 0.11 seconds. That means the period of the oscillation of the simple pendulum is 2.62 plus minus 0.11 seconds, that is, it lies between 2.62 plus 0.11 second, that is 2.62 minus 0.11, or between 2.73 seconds and 2.51. As the arithmetic mean of all the absolute error is 0.11 seconds, there is already an error in the tenth of the second. Hence, there is no point in giving the period to be the 100, and A more correct will be with the right, which is being as T equals to 2.6 plus minus 0.1 seconds here. On the same way, you have to note that the last numerals, that is 6 is unreliable, and on the same way it has been unreliable, and since it may be anything between 5 and 7, we indicate this by saying the measurement that has these two significant figures. In this case, the two significant figures are 2, and which is reliable, and 6, which has an error associated with it. You will be learn more about the significant figures in the sections. For this, the relative error of the percentage error is, and for that we'll have to find out A equals to 0.1 upon 2.6 into 100, which is equals to 4%. Okay, now we talk about for another one, and that is in the combinations of error. In terms of combinations of error, there are many combinations of error that we'll discuss in the next coming class. And but now we'll other than this, we talk about how will you measure the length of a line, and that is of course being important one. And then we'll discuss the rest in the next coming class. So then that is being the of course the 12th class that we'll discuss here. But before ending it up, we'll discuss one of the thing that has been how will you measure the length of a line. So in the same, what a naive question that is at the stage you might say, but what if it is not being a straight line? You have to draw a zigzag line to your copy or on a blackboard. Well, not too difficult. Again, you might take a thread, place it along the line, opens up the thread and measures its length. Now imagine that you want to measure the length of the national highway, a river, the railway track between the two stations, or the boundaries between the two states or the two nations. If you take a string of length 1 meter and 100 meter, that keep it alongside to the line and shift its positions every time, that the arithmetic of a man hours of labors and expenses on a project is not commensurate with the outcome. Moreover, the errors are bound to occur in this enormous task. There is an interesting fact about this and the France and Belgium that shares a common international boundary, whose length are mentioned in the official that document of the two countries differ from the substantially. Go one step beyond that. Imagine a coastline where the land meets seas. Roads and rivers have a fairly mild bend, and to the compare to the coastline. Even so, all documents included all the school books contain information on the length of the coastline of Gujarat and Andhra Pradesh and the common boundaries between the two states, etc. Railway tickets come with the distance between the stations printed on them. We have milestones all along with the road indicating the distances in the various towns. So how was it done? One has to be decide how much error that one have to tolerate to optimize the cost effectiveness. If you want smaller errors, it will be involving the high technology and the high cost. Suffice it to require the fairly advanced level of physics and the mathematics, engineering, and technology. It belongs to the areas that the fractals that which has lately become popular in the theoretical of physics. Even then, that from the story of the France and Belgium. Incidentally, the story of the France-Belgium discipline appears to the first page of the advanced physics book that subject the fractals and chaos here. So here we're gonna end up with this, and that as I told you, we had done your chapter 1, that has been the physical world, where we had completed your what is physics, scopes and excitement of physics, physics, technology and society, fundamental forces of nature and nature of the physical laws. In chapter 2 we had started with, that has been the introduction, the international system of the units, measurement of length, measurement of mass, measurement of time, accuracy, precision and instruments and the errors in the measurement, significant figure, dimension of the physical quantities, dimension formulas and the dimension equalities, and dimension analysis and its application. After talking about that, we'll be starting with the unit 3rd, which we have to discuss here, is being the motions in a straight line. Your 4th unit is your motions in a plane. Then after that, unit 5 is your laws of motions, work, energy and power, system of particles and rotational motion, and unit 8 is your gravitation. So here we're gonna end up with. Thank you, hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion in the comment box. Thank you, please support us.